Today we are going to look at the Laplace transform of periodic functions. So we have to prove that if f of t is a periodic function, with period equal to capital T, this implies the Laplace transform, that is f of s, will be 1 divided by, this is 1 minus e to the minus st integral 0 to capital T. This is f of t e to the minus st dt. So let's give the proof. All right, so let us start from the Laplace transform of f of t. This is equal to integration 0 to infinity f of t into e to the minus st dt. Okay, so this can be equal to integral, say we write u is equal to 0 to infinity. Instead of 0 to infinity, let us split the terms. Okay, integration 0 to capital T, this is f of u e to the power minus su d plus integration, now u begins at t and goes till capital 2 times capital T into f of u e to the minus su du, and this goes continuously up to this reaches, say, infinity, right? So in general I can do plus dot 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 dot, somewhere at the middle you may get a term such as u is equal to n times capital T to n plus 1 times capital T. Okay, f of u e to the power minus su d, and so on. This will go like this. Now in general, let us try to put it in this way. This is equal to Laplace transform of f of t can be now written as, this is summation n becoming equal to 0 to infinity integration of u equal to n times capital T to n plus 1 times capital T. This is e to the power, okay, that's right, e to the power minus su into f of u du. Now let's try to make a substitution here. Let's make every u as t plus nt. So put u equals to small t plus n times capital T. This implies, if at all you want to find a du becoming equal to dt, right? Now u equals to n times capital T. This means the t plus nt becomes equal to nt, because it's repeating, correct? This implies the t becomes equal to 0. Then when u becoming equal to n plus 1 times capital T implies, right, the t plus nt is equal to nt plus capital T. This implies the t is equal to capital T. So also we can write the f of u is equal to f of t plus nt, because of the periodicity, right? That's equal to f of t itself, right? This is by periodicity. So now let us write. This implies, now I can write this back. Therefore, the Laplace transform of f of t, wherever we had stopped, from there we'll continue now. So this is equal to, there is a summation starting from n is equal to 0 to infinity. This is integral t is equal to 0 to capital T. I can write e to the power minus s. What is u? U become t plus nt into f of t dt, right? So I can see that e to the power s nt is a constant, so I'm going to take that out. All right, so this is summation n is equal to 0 to infinity. We take e to the power s n capital T out of this. Then you have integral t is equal to 0 to capital T, 0 to capital T, f of t into e to the minus st dt. Okay, now let us try to substitute this thing. So we can see that there is a summation n, right? N equal to 0 to infinity e to the minus st. I can try to write that as e to the minus st is raised to the power n over here, correct? So this can be written as summation n equal to 0 to infinity. The function is actually e to the power minus st raised to the power n. It should look like a to the power n, because we have a standard formula for that. So this is t is equal to 0 to capital T f of t e to the minus st dt. So this is a to the n is 1 divided by 1 minus a. So this is 1 divided by 1 minus, our a looks like e to the minus st into integration now 0 to capital T function f of t into e to the minus st dt. So since this is, the function is periodic, we have the following notation coming. Okay, now based on this concept, let's start solving problems. So first question, find the Laplace transform of f of t is equal to t squared, right? This is 0 less than or equal to t less than or equal to 2, and f of t is equal to f of t plus 2, right? So this means I have to check this point and compare it with f of t equals to f of t plus capital T. So this implies the period is 2 for this particular function. right? So it is periodic with period 2. That implies, right, I can directly write, therefore f of s is equal to 1 divided by 1 minus e to the power minus st integral 0 to t f of t e to the minus st dt. So this is equal to, let us substitute, this is 1 divided by 1 minus e to the minus s into capital T is 2. So I'll write minus 2s, integration happening from 0 to 2, right? This is t square into e to the minus st dt, right? I'll take t square as the first function. This is u, e to the minus st is v. So we have to apply the Bernoulli's rule to solve this question now. This is equal to 1 divided by 1 minus e to the power minus 2s into, take the first function as it is, that is t square, integrate the second function e to the minus st divided by minus s. To this function substitute 0 to 2, then minus, differentiate the first function. Now t square becomes 2t, integrate the second function once again. So this is e to the power minus st divided by another minus s, but there is already a minus s, so s into s becomes simply s square. Substitute 0 to 2, then so you can see the change in sign, alternatively plus minus coming up. 2t differentiation is simply 2, e to the minus st becomes e to the minus st by minus of s cube. This is 0 to 2 as per the Bernoulli's theorem. So you see that I don't have a fourth term coming up because next time would have been the definition of 2, which is 0. So 0 into any term that comes up is a 0. That's why we are not writing the fourth term over here. Okay, keeping this in mind, let's try to substitute the values. This is 1 divided by 1 minus e to the minus 2s into, so I can take a minus of 1 by s outside this and then substitute, put t over there. This is 4 into e to the power minus 2s and when you put 0 to t it becomes 0. That's the first term. Minus 2 by s square into 2 by s square, put 2 over there. This is 2 into e to the power minus 2s. When you put 0, the whole term becomes equal to 0, plus the last term is 2 by okay, so this is minus 2 by s cube. Let me make that correction. So this is minus 2 by s cube, and when you put 2, it's e to the power minus 2s. When you put 0, e to the 0 is 1. Okay, now let's write the next step. So this is equal to 1 divided by 1 minus e to the minus 2s. Multiply this with minus of 2s square e to the power minus 2s. Then the second term becomes minus 2s into, I can take out a common term now, so that is s cube. Okay, I'm taking the common denominator now. 2s into e to the power minus 2s, and this is minus e to the minus 2s plus 1 whole divided by, this is s cube. So this becomes equal to 1 divided by s cube into 1 minus e to the minus 2s into 1 is positive, then every term is negative. So I can write minus 2s square plus 2s plus 1 into e to the minus 2s. So the whole function is in terms of s. This is the required Laplace transform. Okay, now the next question is like this. F of t is equal to, this is e sine of pi t by omega. 0 less than or equal to t less than or equal to omega, and f of t is equal to f of t plus omega. Alright, so as per the rule, right, if you want to calculate the f of s, this is 1 divided by 1 minus e to the minus st integral 0 to t function f of t into e to the minus st dt. Right, now this implies we have to put the capital T by omega now, because the period is set to be omega. So 1 divided by 1 minus e to the power minus s into omega, integration 0 to omega. F of t is nothing but e into sine of pi t by omega times into e to the minus st dt. Therefore, in the next step, I'm going to write this is equal to, capital E is a constant, we can take it out, divided by 1 minus e to the power minus omega into s. See, integration 0 to omega, right, sine of pi t by omega into e to the minus st dt is a standard integration. So directly we can write the answer. So this is e to the minus st divided by, so we have a square plus omega square, a square plus b square. So a square is s square here, plus b square looks like the pi by omega whole square. This term multiplied by, this is minus s into, this is sine of pi t by omega minus its pi by omega into cos of pi t by omega. Alright, so this is the function. Substitute from 0 till pi, sorry, not pi, 0 to omega, my mistake. Substitute the value as omega over there. Now this is equal to, so this is equal to capital E divided by 1 minus e to the minus omega s into this is 1 divided by s square plus pi by omega the whole square. Now I keep e to the minus st with the term so that I can calculate the values with the substitution. When I put omega over there, this becomes equal to e to the power minus s omega into s sine of pi by omega. So you can see that that term cancels. Then I have minus pi by omega into cos pi. Cos pi is minus 1. So you have pi by omega coming into picture. Then minus, put 0 over there. When you put 0, e to the 0 is 1. That is into, when I put cos 0 is 1. So I have minus of pi by omega coming into picture. So this is now equals to, I can write see, the pi and omega are constant for both of them, correct? So pi comes out, so I can write pi into capital E in the second denominator I have a omega square that's going to come up, omega square whole divided by, we have denominator has a term omega into 1 minus e to the minus omega s into s square plus omega square. So the one of the omega will cancel. So there is there is a mistake in this. So we have to write, you can see that omega s square plus omega square. So there is a omega square s square plus pi square, and then the omega square goes to the numerator, which I already have written. So this into, I can write this as 1, because minus of minus pi is 1 minus e to the power 1 plus e to the power minus s into omega. So we'll write the final term. So this is equal to, this is pi e omega whole divided by, this is pi square plus omega square s square multiplied by 1 plus e to the minus omega s divided by 1 minus e to the power minus omega s. So 1 plus e to the power theta and 1 divided by 1 minus e to the power minus theta is actually a cot hyperbolic function. So it's a standard function, so we can replace this as pi e omega divided by, this is pi square plus omega square s square into, this is cot hyperbolic function of omega s divided by 2 is the required function. The next question is, f of t is equal to t for 0 less than or equal to t less than or equal to a, and this is 2a minus t. So this is when a less than or equal to t less than or equal to 2a, and f of t becomes equal to f of t plus 2a. So this gives us an idea that the given function is periodic. So I should apply the rules of periodicity to calculate this integral. Okay. We'll write Laplace of f of t, that is capital F of s, is equal to 1 over 1 minus e to the minus st integral 0 to capital T f of t e to the minus st dt. So this is equal to, now we'll split the integral. Okay, so we can write this as 1 divided by 1 minus e to the power minus 2a into s, because the period looks like 2a for us. Then integral splits. This is 0 to a. Between 0 to a, the function is simply t into e to the minus st dt, plus this is a to ta, 2a. This is 2a minus t e to the minus st dt. So this has to be equal to 1 divided by 1 minus e to the minus 2as into, so let me write the first integral, the solution of the 0 to a t e to the minus st dt by using the Bernoulli's rule. First function t into integration of the second function e to the minus st divided by minus s minus, this is differentiation of t is 1 e to the minus st divided by minus s whole square is s square. So this function needs to be substituted from 0 to a. Then plus, let's write the second function after integration by applying the Bernoulli's rule. I'll write it below. This is plus okay, this is first function 2a minus t into, this is e to the minus st divided by minus s minus 1 into the integration further minus st by minus s square is minus of s square is s square. So this is a to 2a. Okay, going further, now this becomes equal to, so I am substituting a to this the first term first, then I put 0, right? So this is 1 divided by 1 minus e to the power minus 2as into, now I'll take minus 1 by s outside the first term, then I substitute a there. It is a into e to the power minus as minus 0. Then from the second term, I will extract the 1 by s square, minus 1 by s square out. So this means e to the minus as minus 1. Then from the next term, I'll take out the 1 by s outside. When you put the 2a minus 2a is 0. So minus a into, this is e to the power minus as. Then the last term is plus 1 by s square is taken common. This is e to the power minus 2as minus e to the power minus as. Okay, so we have the terms coming up like this. Therefore, in the next stage, let us simplify this further. So I can see that I can make the common denominator as say s square. So I'll take that term out of the bracket. So let me write s square into 1 minus e to the minus 2as, okay, into, so s square, when you take the term completely out, right, I'm going to get minus of e to the power minus as, then we have 1 over there, then we have plus e to the power minus 2as minus e to the power minus as. So this can be further equated to, let's write it as 1 divided by s square into, this is 1 minus e to the power minus 2as into, this is 1 minus 2 times e to the minus as plus e to the minus 2as, right? So we can write this as, so the numerator is a perfect square. I can write it as 1 minus e to the minus as whole square divided by denominator is s square into, see, this is a square minus b square. I can write a plus b, 1 plus e to the minus as into 1 minus e to the power minus as. So out of this we can eliminate one of the terms. So 1 minus e to the minus as and this. So if you remember, 1 minus e to the minus as by 1 plus e to the minus as is a tan hyperbolic function. So this is 1 by s square into tan hyperbolic of the as by 2. This is the required answer. Let's go to the next question. F of t equals to 1 divided by, okay, the f of t is given as e times sine of omega t for 0 less than or equal to t less than or equal to pi by omega, and 0 for pi by omega less than or equal to t less than or equal to 2 pi by omega. And it mentions that f of t is equal to f of t plus 2 pi by omega. Alright, so now let's try to find the Laplace directly. Laplace transform f of s is equal to, it's a periodic function, so this is 1 divided by 1 minus e to the minus st integral 0 to capital T, the given function f of t into e to the minus st dt. Okay, so this is equal to 1 divided by 1 minus e to the power minus s into 2 pi by omega, because the period is 2 pi by omega. So integral 0 to 2 pi by omega into the given function. I'll write f of t itself because e to the minus st dt, because the f of t is not completely defined, right? So what we can do now, it's defined only from 0 to pi by omega. So this is 1 divided by 1 minus e to the power minus, I can write 2 pi s by omega integral 0 to, this is only pi by omega. Then I'll write capital E sine of omega t into e to the minus st dt. So take the capital E out of this integration as it is a constant. So E divided by 1 minus e to the power minus 2 pi s by omega, right? Integration of 0 to pi by 2, e to the minus st sine omega t is a standard integral, right? So the result you can directly write without integrating. So e to the minus st by, this is s square plus omega square into minus s into sine of omega t minus omega into cos of omega t. So this is the substitution you are going to make from 0 to pi by omega. Alright, so in the next step, this becomes equal to, let us write, I think minus is common for both of them. I'll write a minus also. I'll take the minus minus e divided by s square plus omega square is a constant. I'm substituting for t, so any term which does not have a t is a constant. So this is 1 minus e to the power minus 2 pi s by omega into, I have the s square plus omega square also coming out. Okay, then let us substitute into, so e to the power, first I am substituting the t is equal to pi by omega, so e to the power minus s into pi by omega into, this is s sine pi plus, this is omega cos pi, right? That's the first term, minus e to the power 0, because I'm going to put t 0. So the term becomes s into sine 0 plus omega into cos 0. This is equal to the minus e whole divided by, this is s square plus omega square into 1 minus e to the power minus 2 pi s divided by omega into, we have minus omega because sine pi is 0, so that term cancels out. We have minus omega into e to the power minus s pi by omega minus omega. So this should look like, when I take the minus outside, minus of minus will cancel. So I have e into omega into, this is 1 plus e to the power minus pi s by omega whole divided by s square plus omega square 1 minus e to the power minus 2 s pi by omega. So denominator is a square minus b square format. I can actually split this as a plus b into a minus b. So therefore this is equal to e into omega 1 plus e to the power minus pi s by omega whole divided by, this is s square plus omega square into, say this is 1 plus e to the power minus pi s by omega into 1 minus e to the power minus of pi s by omega. So we can cancel these two terms. So as a result, we are going to get the final answer, that is the Laplace transform is equal to omega times capital E divided by, this is s square plus omega square into 1 minus e to the power minus pi s by omega. This is the required answer.